taken a bet on areas what we think we can make most impact. We're also always learning. That's why we're here. See what everyone else is up to and see what else we can target. The second pillar of our strategy is we've got to build a what we call like cross-cutting primitives. There's foundational AI technologies that is pretty much in all your solutions. You'll probably feel it too. And having the right abstractions in place, the right frameworks, right tooling helps us build more solutions and build them faster. And lastly, what I'd say is probably the cornerstone of this strategy is what we call intentional tech transfer. We've taken a bet on a few product areas. We want to build them. We want to build them as fast as possible. But we do stop and be deliberate about, hey, what here is reusable? What can be spun out into something that reduces the barrier for the next problem we want to solve? And so LangFX is our opinionated framework we built that apps like LangGraph and LangChain. It makes it work better with Uber systems. And it was born out of necessity, right? We had the first couple of products emerge and they wanted to solve problems in an agentic manner. They wanted to build a usable nodes, and like LangGraph was the perfect way to do it because we saw it was proliferating across the organization. We made it available and we built a opinionated framework around it. So, I think enough of the view. Let's just dive into one of the products. Martin, can you walk us through Validator?
Yeah, absolutely. So the first product we'll showcase today is called Validator. Now, what it is an NID experience that flags up best practices, violations, and security issues for engineers in code automatically. So it is effectively a LangGraph agent that will build a nice ID UX around. And let's take a look at how it works. So we have a screenshot here that shows a user opening profile, and what they have there is they're notified of a violation in this case. So they have a little bit of a diagnostic that they can mouse over, and they get a nice model saying, hey, in this case, you're using the incorrect method to create a temporary test file. This will leak into host. You want to have it automatically clean up for you. So what do you do about it? What can the user do? Well, they have multiple choices. They can apply a pre-computed fix that they have to care for them in the background, or if they choose so, they can ship off the fix to their ID agentic assistant that they prefer. So that's what we have in the next slide actually is the fix request has been shipped off, and we got back a fix from the ID. And so the issue is no longer present, and the user's happy with the issue is resolved. They no longer have to lose now. So that's super. Some of the key ideas that we found out about building this, the main thing is that the agent abstraction allows us to actually compose multiple sub-agents under a central validator for now, for example. So we have a sections, a sub-agent for a validator that calls into the LLM with a list of practices and sort of gets those points of feedback resolved or returned. But there's also a deterministic bit where, for example, we want to discover lint issues from static linters. So there's nothing stopping us from running a lint tool and then passing on the rest of the graph that allows us to pre-compute a fix even for those. So that's the learning. And in terms of impact, we're seeing thousands of fixed interactions a day from satisfied engineers that fix their problems in code before they come back later to find them.
And I think, we think we've built a compelling experience. Right? We met developers where they are in the IDE. We have tooling that runs in the background. We can combine, the deterministic capabilities like we use case part tool. We find out where the test boundaries lie. We're able to evaluate these against a set of curated best practices, flag up violations, figure out what the most expressive way to deliver this back to the user, short of the ID, give them a way of applying fixes. But we thought, why stop there?
For sure. So why stop at validating? Let's help engineers by authoring their tests from the get-go. Now, the second tool we're showing you up here is called AutoCover. And it is a tool to help engineers build, or generate, rather, building, passing, coverage raising, business case testing, and validated and implementation tests. So like really high quality tests is what we're shooting for here. And the intent is to save the engineer time. So they're developing code, and you want to get their tests quickly and move on to the next business feature that you want to implement. So the way we got to this is actually we took a bunch of experts, domain expert agents. We actually threw in Validator there as well, and more on that later. And then we arrived at the test generation tool. So let's take a look at how it works. We have a screenshot of Go source graph. tests a whole bunch of stuff happens in the background. So we start with adding a new target to the build system. We set up a test file. We run an initial coverage check to get a sort of a target space for us to operate on. All while that is being done, we also analyze the surrounding source to get the business context out so that we know what to test against. And what the user sees really is just they get switched to an empty test file. In this case, it could also be populated. And then, because we did all that stuff in the background, we're starting to already generate tests. And what the user will see is they'll see a stream of tests come in. And then the file will be in constant flux. There will be tests coming in at fast speed. We'll do a build. This test that fast, we'll take it out. Some tests might get merged. Some tests might get removed because they're redundant. You might see benchmark like concurrency tests come in later. And so, the user is sort of watching this experience. And then at the end, arriving at a nice set of validated vetted tests. That's what we want. That's the magic we want for our users here. And that's what we want. Let's dive a bit deeper into the graph here to see how it actually functions. So here's the graph. On the bottom right, you can actually see validator, which is the same agent that we just talked about previously. So you can already see some of the composability learnings that we found useful. So how do we arrive at this graph? We looked at the sort of heuristics that an engineer would use while writing tests. And so for example, you want to prepare a test environment. You want to think about which business cases to test. That's the job of the scaffolder. Then you want to think of new test cases, whether it be for extending existing tests or just writing new tests altogether. That's the job of the generator. And then you want to run your builds, your tests, and then if those are passing, you want to run a coverage check to see what you missed. That's the job of the executor. And so we go on to complete the graph this way. And then because we no longer have anyone involved, we can actually supercharge the graph and sort of juice it up so that we can do 100 iterations of code generation at the same time, and then 100 executions at the same time. We've seen, for a sufficient source file, you can do that. And that's sort of where our learning comes in is we found that having these super capable domain expert agents gives us unparalleled performance, sort of exceptional performance compared to other agentic coding tools. So we benchmarked it against the industry agentic coding tools that are available for test generation. And we get about 2 to 3 times more coverage and about half the time compared to them because of the speed ups that we did in creating this graph here. And so the custom bespoke knowledge that we built into our agents. And in terms of impact, we this tool has helped raise developer platform coverage by about 10%. So that maps to about 21,000 dev hours saved, which we're super happy about. And we're seeing continued use of thousands of tests generated monthly. So that's very happy about that. Sourabh, take us through some more products.
Yeah, so we don't want to stop at 5,000 tests a week. Like we built these primitives, right? Just wanted to give you a sneak peek of what else we've been able to do in the organization with this. So what you see on screen right now is our Uber Assistant Builder. Think of it like our internal custom GPT store where you can build chatbots that are steeped in Uber knowledge. So like one of them you see on the screen is the security scoreboard, and it has access to some of the same tools that we showed you earlier. It knows it's steeped in Uber's best practices. It can detect security anti-backers. So even before I get to the point of running my IDE writing code, I can ask questions about architecture and figure out whether my implementation is secure or not. Right? Same primitives powers different experience. Next up, we have Picasso. Picasso is our internal workflow management platform, and we build a conversational AI, we call it Genie, adopt that. It understands workflow automations, it understands the source of truth, and it can give you feedback grounded in product truth, like aware of what the product does. Third thing I want to show you, and this is not an exhaustive list, right, is our tool called U-Review. Obviously, we build stuff in the ID, we try to flag anti-patterns earlier in the process, but sometimes things still slip through the crack. Why not reinforce and make sure quality is enforced before, code gets landed, before your PR gets merged. So again, powered with some of the same tools that you saw earlier, the power like validator and test generator, we're able to flag, with code review comments and code suggestions that developers can apply during review time. I think with that, we'll just jump over to the learnings.
Yep, sounds good. So in terms of the learnings, we already sort of talked about this, but we found that building domain expectations that are super capable are actually the way to go to get outside results. So they use context better. You can approach things in rich state. example of a domain expert that's super capable and gives us that performance that we want to keep. Secondly, we found that when possible, composing agents with deterministic sub-agents, or just have the whole agent deterministic makes a lot of sense if you can solve the problem in a deterministic way. So, one example of that was the lift agent under validator. We want to have reliable output, and if we have a deterministic tool that can give us that intelligence, we don't need to rely on LLM. We can have that reliable output and pass on the learnings to the rest of the graph and have them fixed. And then third, we found that we can scale up our dev efforts quite a bit by solving a bounded problem by creating an agent and then using it in multiple applications. So you already saw it with validator, the standalone experience on validator with autocover for test generation validation. But I'm going to give you one more lower level example, and that's the build system agent. That's actually used for both of those products. That's just a lower level abstraction that is required for us to be able to have the agents be able to execute builds and execute tests in our build system. So Sourabh, take us through some of the strategic learning.
Yeah, so Manav talked us through some of the tech benefits, but this is the one I'm probably most excited to share. Like, you can set up your organization for success if you want to build agentic AI, and I think we've done a pretty good job of it at Uber. We haven't evolved into an AI arms race. We're all building in collaboration, and I think these are our biggest takeaways. The first being just encapsulation with collaboration. When there are well thought out abstractions like LangGraph, and there are opinions on how to do things like handle state management, how to deal with concurrency, it really allows us to scale development horizontally. It lets us tackle more problems and more complex problems without creating this operational bottleneck, right? An example I'll give you is our security team was able to write rules for validator, like the product we focused earlier. It's able to detect security anti-pattern, but the security team knew nothing about this part of the security. Knew nothing about AI agents and how the graph is constructed, but they were still able to add value and improve the lives of our developers. And so, like a natural segue from that is if you're able to encapsulate, work into these well-defined nodes, then like graphs are the next thing to think about, right? Like graphs help us model these interactions perfectly. They often mirror how developers already interact with the system. So when we do the classic process engineering and identify process bottlenecks and inefficiencies, it doesn't just help accelerate or boost the AI workflows, it also helps improve the experience for people not even interacting with the AI tools, right? So it's not like a hunch, it's either or should we build agentic systems or should we improve our existing systems? It usually segues into like helping each other. Like just, we spoke about our agentic test generation, and we found multiple inefficiencies through like how do you do mock generation quickly, how do you modify build files and both like interact with the build system, how do you even execute the devs? And in the process of like fixing all these paper cuts, we improved the experience for just like non-agentic applications, just for developers interacting directly with our systems, and it's been hugely beneficial. And with that, I want to bring this up to an end. We really enjoyed presenting here. Thank you for the opportunity.